Welcome 8th graders. Please turn to Lesson 6 Scientific Notation on page 51 in your math booklets. We're looking at the real world link. Electronics. A single-sided, single-layer DVD has a storage capacity of 4 and 7/10 gigabytes. 1 gigabyte is equal to 10 to the 9th bytes. Write a multiplication expression that represents how many bytes can be stored on a DVD. Complete the table below. Okay, they started the first one for us with 4 and 7/10 times 10 to the first, and they got their product of 47. So we're going to do 4 and 7/10 times 10 to the second power, which would give us 470. 4 and 7/10 times 10 to the negative 2 would give us a 0.047 or 47 thousandths. 4 and 7/10 times 10 to the third would give us 4,700. To the negative third would give us a 0.0047, which is 47 ten-thousandths. 4 and 7/10 times 10,000 would give us 47,000. And then 4 and 7/10 over 1 over 10,000 would give us 0.00047. Please make sure that you have done these same problems in your book on page 51. If 4 and 7/10 is multiplied by a positive power of 10, what relationship exists between the decimal point's new position and the exponent? When the power is positive, the number of the exponent gives the number of places the decimal point moves to the right in the product. When 4 and 7/10 is multiplied by a negative power of 10, how does the new position of the decimal point relate to the negative exponent? When the power is negative, the number of the exponent gives the number of places the decimal point moves to the left in the product. Key concepts. Scientific notation is when a number is written as a product of a factor and an integer power of 10. The factor must be greater than or equal to 1 and less than 10. They have an examples of symbols and real-world examples. Use these rules to express a number in scientific notation. If a number is greater than or equal to 1, the power of 10 is positive. If the number is between 0 and 1, the power of 10 is negative. Write each of these numbers in standard form. For number 1, we had 5 and 34 hundredths times 10 to the fourth. We had to move the decimal point 4 places. We started between the 5 and the 3, and then we moved it 1, 2, and then we had to add 2 more zeros to make a total of 4 places. When we're moving negative numbers, it's going to be the same thing, but just we're going to move our decimal point to the left. So it's between the 3 and the 2, and we need to move it negative 3. So that's 1, 2, 3, and that's where our new decimal point goes. Let's try these examples. Number 1, 7 and 42 hundredths times 10 to the fifth. So we have our 7 and 42. That's 2 places we moved, and now we need to add 3 more zeros. When we have 6 and 1/10 times 10 to the negative 2, we have our 6 and our 1. It's a negative, so we moved it 1 place here, and we need to add 1 more zero and our decimal point 0. 3 and 714 thousandths, we're going to move 2 places. It's originally here, but we're not going to keep it there. So we're going to have 3, 7, 1, decimal point 4. Looking at example 3 and 4, we were able to practice writing each number in scientific notation. So 3,725,000 can be written as 3 and 725 thousandths times 10 to the sixth. For number 4, we have a negative exponent because this number is less than 1. We need our decimal point to go between the 3 and the 1, so we have a number between 0 and 1. So we would have to move it 1, 2, 3, 4, and that's how we got the negative 4. Okay, we would like you to complete letters D, E, and F for homework in your booklet, and you should be on page 53. Have a great day!